Hi, in this video, I'm going to talk about LeetCode 784, letter case permutation. You are given a string S and it can transform every letter individually to be uppercase or lowercase. And be mind that we don't have to transform the number. So for example, for this one, we can have 4 permutations because first one is like 2 lowercase, and this one has B uppercase, A uppercase, and both uppercase. So this would be all the possible permutation for the letter case. And when we talk about permutation, we know that this question is about backtracking, right? So we'll be using backtracking to solve this question. At first, this is your string, right? It's A1, B2. For the first one, and for the first character, we can make it uppercase or lowercase. So in this case, the first one is lowercase and the second one is uppercase, right? Now we'll be changing B. The first one will be A1, B2, and the second one will be A1 with B uppercase. And the same applies for the uppercase part. So these are all the possible combinations. Therefore, at first we can convert this to uppercase, then we can go through this and backtracking, then we can make it back to lowercase and continue backtracking. And we're gonna have a point to like where we are at now. So for example, for this one, it's currently here, right? Then for after we go here, we have to move the pointer to B. And when there is and when the pointer reaches here, we can just add it to the result. And result will be the vector to store all the possible permutation. And now let's try to do this. So at first, we have to create a result string. And then we need a backtracking method. We'll pass in the string, the current S, and then the position. You start at 0 and result. And the end, we're just going to return result. So now the main point is about the backtracking method. Why backtracking? We are passing S here and the position and also the results. We know that we don't have to convert and or transform the numbers, right? So currently, if S is less than the length, if position is less than S of length, and currently the position is pointing to a digit, we just need to move it. We're just gonna move position. And after this value ends, it will be either at pointing to a alphabet or reaches the end, right? So if it reaches the end, we have to append the current string to the result. So if position is equals to S dot length, we are going to append it, push back, and return. And return. The reason why we are putting equals here and not equals to S length minus 1 is because for this while loop, right? If there's a digit here at the end, it will still add position by 1. So at the end, position is actually here. So which is equals to the length of the string. After that, we'll use the XOR operation. So we'll XOR with 32. The reason why we are using 32, we can refer to the ASCII table. So for example, A is 41 hexadecimal, right? And the lowercase is also 61. So if you convert 41 hex to binary, it's 10000001. If it's 61 here, you can say it's only changing a bit here. So only change this bit. Therefore, just gonna XOR with 32. Then we perform backtracking again with the current string, and we have to add position by 1 with the current result. After we are done with the backtracking, we have to convert it back to the normal one. And backtracking again. And after you're done with all the backtracking, the result contains all the possible permutations. And that's all for this video. Thank you.